Okay, now we are going to do some particular sums on continuity. Okay, the first sum is we have to check the continuity of the function f given by f at x is equal to 2x plus 3 and x equals to 1. That is, we are given f at x is equal to 2x plus 3 and we have to check continuity at x equals to 1. Check continuity. We have to check continuity at x equals to 1. Okay, so now what is the procedure? I told you have to find first of all f at x is given, you have to find first of all f at 1. So what is f at 1? F at 1 will be, in place of x I will be replacing 1, so I will get f 2 into 1 plus 3. 2 plus 3 gives me 5. Okay, now you can see over here that here we are not required to check for left hand limit and right hand limit, because for left hand limit also and for right hand limit also it is defined in same way. So here directly we will be checking the initial definition which I showed you, limit x tends to f at x exists or not. So let us see, limit x tends to a, or that is, in place of a we have 1, so limit x tends to 1, f at x is equals to limit x tends to 1 to in what is f at x? 2x plus 3. So we will write 2x plus 3. So now it is not 0 by 0 form, so I will be replacing over here 2 into 1 plus 3. So again 2 plus 3 will be equals to 5. So you can see over here, your first condition is f1 you have to find and it exists, limit x tends to an f at x, it exists, and also they both are equal. See, both are equal. So here we have limit x tends to 1, f at x is equals to f at 1. Therefore given limit, or you can say given function is continuous at x equals to 1. Okay, now we are going to do second sum, that is f at x is equal to x square. You have to check continuity for f at x equals to x square and x equals to 0. So as per the thing, f at x is x square. So what is f at 0? We have to find at 0. 0 square, 0 square is 0. Okay, first thing we have done. Second thing, limit x tends to 0, f at x. F at x is x square, so limit x tends to 0, x square. Now by putting x equals to 0, here it is not 0 by 0 form, so you can replace this value. So I will get 0 square equals to 0. These also exist, and both have same value. So by definition you can say that limit x tends to 0, f at x is equals to f at 0. Therefore function f is continuous at x is equals to 0. Now we are going to third sum. It is somewhat different than the first and second we have done. F at x is equals to mod of x at x equals to 0. Okay, here it is mod of x. So you know definition of mod of x, right? So first of all let me define mod of x. Mod of x is actually x if x is greater or equals to 0, and minus x if it is x is less than 0. This is how x is defined. So here for positive value n equals to, it is defined in this way, and for negative value it is defined in this way. So for this, when it is defined in different way at 0, then I have to take LHL and RHL. Okay, so first of all I will find out f0. My first step is f0. F0 n equals to 0, so f at x only, so it will be 0. Okay, now LHL, that is left hand limit. Left hand limit, limit x tends to, at 0 we have to find, so 0 minus. We have to find at 0 only, and it is, see, defined in different way at 0 only. So we will directly take f at x. Now what is the function, that is how it is defined for less than 0. For less than 0, f at x is minus x. So I will replace in place of f at x as minus x. Now if I replace this 0 over here, then it is 0 by 0 form? No, it is not 0 by 0 form. So I can replace it 0 directly. You know that minus of 0 is 0 only. Now I will find RHL. That is x tends to 0 plus. LHL, 0 minus means for value x less than 0. RHL, x tends to 0 plus means for value x greater than 0. Okay. So for greater than 0, How it is defined? How this function is defined for greater than 0? Yes, it is equals to x. So for greater than 0, it is defined as in this way. Now you can see that if I replace this value, okay, if I replace this 0 over here, then it will not be 0 by 0 form. So I can replace this 0. Now f0 is 0, LHL 0, RHL 0. All three exist and all three have equal value. So you can write over here. Therefore, LHL equals to RHL is equals to f at 0. Therefore, function f is continuous at x equals to 0. Right. Now, what does this mean? LHL means what? It is continuous on left hand limit. RHL means what? It is continuous on right hand limit. So, for less than 0, it is continuous. This, for greater than 0, it is continuous. This, if these three values are equal, then means at that point also it is continuous. So, it is continuous throughout, and also it is continuous at this point.